Our universe is one of massive and incomprehensible scale, accentuated by no less than 70 sextillion stars, desert gardens of light pervading the dull. There are more stars in our universe than there are grains of sand on each ocean side on the planet. A ludicrous number resists human cognizance. However, in spite of this overflow of vast milestones, there's a sure incongruity that we live in a universe where the stations of concentrated matter are rare. On the off chance that each star were for sure contracted down to the size of a grain of sand, then the regular detachment between each grain would be around 6 miles. So that is somewhat the separation from here at Columbia to downtown Manhattan in the Greenwich town. Now that distance, which is around 4 light-years returning to actual units, is perfect to the point that it addresses an enormous test to our cutting-edge space apparatus. For instance, it would take our most far-off shuttle, Explorer 2, an additional 80,000 years to navigate such a distance. What's more, that is only a closest star. The closest universe is a portion of multiple times farther than this. When confronted with such legendary distances, such timescales, it seems like the universe basically precludes the fantasy of human space explorers truly investigating the profundities of room. Like a grandiose joke prodding us with gems of investigation which will constantly be far off. Furthermore, it's on occasions such as these that we will generally dream of different arrangements in view of colorful material science, for example, twist drives or wormholes. Yet, supposedly, these are hypothetically unlikely, and utilizing truly demonstrated physical science? In our new recordings, we examined the corona drive as a potential means for interstellar travel, yet even that framework isn't quickly enough to get you to different worlds. Strikingly, there is a stunt utilizing demonstrated physical science that could permit an individual to go between even far-off systems on a human lifetime. Yet, such as making an arrangement with Satan, it comes at such a lofty value that you probably won't rush to need to join, an expense that arises as a characteristic outcome of Einstein's extraordinary hypothesis of relativity. Today, we will be going on an outing installed the continually speeding up rocket. We should envision that we have developed a boat fit for advancing at 1G however long we like. That implies that its speed increments by 10 ms for every single second that ticks by. So for instance, following 10 seconds it will go at 100 meters each second and take care of a distance of a portion of a kilometer. We're about to leave to the side the issue of how a spaceship could really direct such an accomplishment for the second, and expect it is valid, and that is essentially to keep this video zeroed in and on the money. What's more, likewise, we will expect that a spaceship has wonderful protecting fit for enduring any sort of effect or radiation you can envision. One advantage of the consistent speed increase would be that this would push the group back towards the back of the boat, with the very force that the Earth pins us to the ground, consequently making counterfeit gravity something we've talked about in our past video in substantially more profundity. Thus, life on board would be somewhat charming, working and living similar as we do here on the planet. A boat that goes through steady speed increase begins slow, yet picks up ever more speed after some time as its journey proceeds. So this is a piece like self-multiplying dividends. Your benefits looks more. Regardless, however, over a significant stretch of time, those gains quickly collect. After only over 2 hours, we would have cruised past the moon. Following 1.5 days, we'd be at Mars. Furthermore, following 3 weeks, we'd have overwhelmed Explorer 2 and left the nearby planet group by and large. By this point, a boat would go at 40 million miles each hour, or around 6% the speed of light. That is far quicker than any spaceship we've constructed has at any point voyaged. It's quick, however, it's not quickly enough for Einstein's hypothesis of exceptional relativity to truly become an integral factor yet. As we leave the planetary group, we head out towards our closest star framework, Alpha Centauri, and see its steadily expansion in brilliance as we approach, while the sun cancels into simply one more bit of light behind us. The following year is genuinely predictable. Life on board is likely fairly every day as the days, long stretches of time tick by. However, with every day your boat goes around 2,000 miles each hour quicker than it did the other day. It's currently difficult to have a live discussion with your loved ones back on Earth, the time it takes for radio waves to go this way, and that is presently numerous months. However, the dejection is to some degree lightened by normal letters from home, refreshing you about the most recent family news, sports results, logical leap forwards, and political embarrassments back on the planet. Following 15 months into your excursion, your team celebrates crossing the primary light year. You're presently just shy of 1/4 the distance to Alpha Centauri. However, over a third the manner in which as far as outbound excursion time, and that is thanks to the boat's steady speed increase. There's another achievement that you and your team acknowledge you have passed too, and that is the very thing physicists got your Lorentz factor, given by this popular condition here, has now passed an element of 2. That implies that the time enlargement among you and terrestrial spectators is presently a component of 2, and in this manner, terrestrial eyewitnesses would appear to see you moving in sluggish movement on board the boat. Starting here on Einstein's hypothesis of extraordinary relativity will impact you and your boat. That is on the grounds that you are presently voyaging away from the Earth at 87%, the enormous speed limit, the speed of light. Presently, in the event that there were no such breaking point, you ought to hope to cross the speed of light in 45 days' time. Yet Einstein's hypothesis, a hypothesis which has been thoroughly verified back on the planet, expresses that nothing can move quicker than the speed of light. Additionally, all spectators, regardless of what their speed, will constantly notice the speed of light to be something similar. Presently, this is extremely non-instinctive. In the event that a pony pursues down a moving train, the train gives off an impression of being moving more slow than expected, according to the pony's point of view. Yet relativity says that regardless of how quick that pony is running, on the off chance that the train is a light emission, it will constantly seem to subside away at the very same speed, the speed of light. The pony can never make up for lost time. In the event that the speed of light is a steady to all onlookers, the brain-twisting result is that existence are not consistent. They shift to oblige this standard. Furthermore, that is precisely exact thing occurs here with our boat. Time moves to such an extent that spectators back on Earth appear to see the group moving more slow than common ready. Furthermore, even space moves with the end goal that the actual boat seems crushed long. Both of those impacts scale with this renowned Lorentz factor, which as of now in our excursion is an element of 2. This even influences your apparent speed increase. According to Earth's point of view, you are presently done advancing at 1g, yet rather your speed increase has all the earmarks of being getting ever more modest as you approach the speed of light. In spite of the reality locally available, you actually feel a 1g speed increase. On board the boat, obviously you and your team wouldn't think anything had changed. Time gives off an impression of being running very much like regular. However, you would see a few weird things beyond the boat. Glancing back at the sun, you'd see that it would have seemed to have blurred into obscurity, a lot quicker than you'd anticipate from basic distance scaling. When your Lorentz factor is 2, it's currently multiple times dimmer, just noticeable with the boat's installed telescope because of relativistic variation and time enlargement impacts. This, yet light from the sun, presently shows up progressively red-moved, because of the relativistic Doppler shift, so red, truth be told, that it currently discharges for the most part in the infrared band where your eyes couldn't in fact see it. Yet, in front of you, the inverse has occurred. Alpha Centauri currently seems multiple times more brilliant than it would in the event that you were not moving, yet the vast majority of its radiation is presently showing up as high-energy bright light. This, as well as the groups of stars in front of you, would seem twisted, distorted into a sort of limited focus deception. In an undeniable manner, as you speed up ever quicker, you start to separate from the remainder of the universe. Yet speeding up always isn't a choice, since we don't have boundless fuel locally available, and eventually we will need to dial back, step off the boat, and reconnect to the remainder of the universe. So one approach to doing this is to speed up your boat up to about the midway imprint in your excursion and flip the boat over on its head and advance the other way, hence halting you at some far-off objective. Presently, how about we stay with our unique objective, that is Alpha Centauri, which is 4.4 light-years away. Recollect that this implies that a light emission radiated from Earth would require 4.4 years to arrive at Alpha Centauri. However, in light of the time enlargement impacts on load-up, you would land your boat on one of the Alpha Centauri planets, having matured only 3.5 years. You can definitely relax. You didn't beat a light emission here, on the grounds that, as per timekeepers, back on the planet, the excursion took you 6 years. Perhaps you put in half a month investigating this new planet then, at that point, head back locally available and make the return venture home. At the point when you become back home, around 7 years would have passed for you, however 12 years for everyone back on the planet. Not a terrible timescale to finish an excursion to the closest star. Review that your boat began decelerating at the midway imprint, 2.2 light-years from Earth. That sounds around 1, really. 8 years into your excursion, according to your point of view, when your boat would go at 95% the speed of light. We should envision that a battle broke out ready, and the team concluded that they would have rather not gone to Alpha Centauri any longer. They needed to utilize all of this energy to go further, far farther than anybody longed for. Presently recollect that we're thinking about here just full-circle situations. We'll loosen up that suspicion later. However, for the time being, any excursion is characterized by 4 stages: outbound speed increase, outbound deceleration, inbound speed increase, and afterward inbound deceleration. Considering that, review that a full circle to Alpha Centauri would require 7 years for the group. However, presently how about we go farther? Our sun lives inside a district of room of somewhat higher hydrogen gas thickness than expected, a locale around 30 light-years across and energetically known as the neighborhood cushion. A boat which makes an excursion to the edge of this neighborhood cushion would mature 13.4 years during their experience. Upon return, they'd observe that their kids were currently more seasoned than they were, having matured those 4 years, in addition to another 50 bringing about a few weird reunions. No one trusted me, yet I realized you'd return. How? Since my daddy guaranteed me. Maybe the team are not happy with simply leaving this nearby cushion, however. Maybe they vote to go further. The nearby air pocket is a bigger volume where the neighborhood cushion itself lives an assortment of a huge number of stars crossing 300 light-years across. In a 1G spaceship, the team will actually want to travel to the edge of the nearby air pocket and return back, and just 22 years would have passed for them. In any case, when they return to Earth, they would be authentic relics, as 6 centuries would have passed back on the planet. Maybe the team would be stunned and estranged by the progressions which had changed society in those 6 centuries gone by. We should go further and set a full circle to leave our cosmic twisting arm, the Orion Spike, for which the full circle would require 31 years for the team. This is where things get bizarre. Recollect that your process is described by 4 stages, and toward the finish of that first period of speed increase, you're hitting your pinnacle speed. So assuming you're traveling out to the edge of the Orion Spike, that first stage would take you around 8 years. Yet, after around 6.5 years, you and your group would watch out of the front window, and you would see something exceptionally weird. 66% of the way into your 7th year of movement, a little fix of the sky ahead seems as though it's sparkling red. At first, you think the eyes are just pulling pranks on you after such countless years in space. However, at that point, you understand that your Lorentz factor is 650. Furthermore, the leftover radiation from the huge explosion, the grandiose microwave foundation, has now blue-moved as far as possible from the microwave to noticeable red light. Over the course of your now last year of outbound speed increase, you and your team are flabbergasted to see this little fix of the sky ahead become ever more splendid, ever bluer. until at its pinnacle speed it resembles gazing down into the eye of an inestimable rainbow, as though the boat has now at last got the look of the actual universe. Maybe not happy with leaving the Orion prod, you rather decide to travel to the edge of the cosmic system itself a full circle for the group of 41 years. Having gotten back from their 100,000 light all-year trip, the group, presently in their 60s, would get back to an Earth which had seen 100 centuries cruise by. It's truly challenging to envision how people would have changed after such a long time scale. Maybe our predecessors would appear to be unique after such countless ages of slow development. Maybe they would communicate in totally various dialects to the ones we perceive today. Perhaps they would have even deserted innovation and returned to a more Neolithic approach to everyday life. Perhaps the actual Earth is deserted as of now, and there are no hint of people on the Earth by any means. Whatever occurs as of now, the boat's PC data set probably addresses an old library containing data tragically missing to the ages of time back on the planet. Be that as it may, this is all still inside our own universe. Imagine a scenario in which we go genuinely to the past, to another cosmic system out and out. How about we go to Andromeda? In a long-term, legendary full circle, you and your team returned in advanced age to Earth, having borne observer to another cosmic system firsthand. However, back on Earth, there is possible nobody even conspicuous as human by this point, with 5,000 years having cruised by. You and your team are probably the last people known to man. Despite the fact that there were no people left, the Earth is more appealing than you've at any point seen it. Biodiversity has nearly recuperated to pre-human levels. Coral reefs have recuperated across the planet and urban areas, and cement have vanished as nature has now recovered what was dependably hers. On the off chance that we wish to wander further abroad than Andromeda, we might begin to require life expansion advancements for the team. Traveling past our group of systems, the Virgo bunch, would require a full circle of 67 years for the team. The Virgo group lives inside the Laniakea supercluster of universes, a locale of room crossing a huge number of light years and containing a huge number of cosmic systems. Your full circle currently would require 76 years. At top speed during that excursion, your Lorentz element would be 250 million a speed of 0.999999998 times the speed of light. By this point, the inestimable microwave foundation will have seemed to have expanded from his encompassing 273 Kelvin temperature to more than 1 billion degrees Kelvin. That is the temperature that the universe was after only a couple of moments after the enormous detonation itself. Obviously, this would be a very perilous radiation climate for yourself as well as your team, also the now over-the-top safeguarding necessities to safeguard against influences. At times, you hear it expressed that as you get to relativistic paces, the force of the boat increments. Such a lot of that in some way safeguards it from influences. However, according to the point of view of the boat, it isn't moving, it is the particles, the space trash out there, that has the outrageous energy, and in this manner impacts with these little particles wouldn't be for weak-willed. In the wake of finishing your 76 all-year excursion to the edge of the Laniakea supercluster, your home framework would be scarcely unmistakable. Arriving on the planet, land masses would have moved into new positions. The surface is presently without any trace of plants or creatures, and you can as of now not even inhale the air around you. Throughout recent years, the sun's glow has now expanded by practically 10%, which thus has expanded the pace of enduring on the Earth. That enduring has taken out carbon dioxide from the air to such an extent that photosynthesis is currently, as of now, not conceivable, finishing the downpour of plant-based life, stopping oxygen creation, and imploding the natural pecking order. By this point, even plate tectonics might have turned down as water dissipates from the world's surface. These future, the last long stretches of multicellular life on the planet, past this point, just straightforward microbial life, will actually want to stick on to presence for perhaps 200 or 300 million years. Best case scenario. The living Earth is wheezing her final gasp. Thus, I figure it would be a distressed get to come once again to your home planet and see it not make a dramatic exit, however, be choked with a sluggish, somewhat long, brutal demise, maybe helping you to remember the destiny which probably looks for yourself, as now even your own body is feeling the impacts of time. One could propose that there's not a really obvious explanation for why Laniakea ought to be the breaking point to these sorts of full-circle trips. After all, the time enlargement is presently outrageous to the point that we can travel dramatically further as time passes. To be sure, you once in a while hear it guaranteed that we might make a trip to the edge of the noticeable universe utilizing consistent speed increase. Those are systems about 46 billion light-years from us. In any case, regardless of the amount we speed up, regardless of how outrageous time expansion becomes, we will always be unable to arrive at the edge of the recognizable universe. Presently, for what reason should this be? Well, when we discuss excursions of billions of light years, then the development of the actual universe begins to impede our journey. In 1998, two groups of stargazers utilized far-off supernovae to autonomously find that the pace of the universe's development, something known since Edwin Hubble's time, was as a matter of fact expanding. It was itself speeding up. We don't completely comprehend the reason why this is occurring. However, the reason is generally named dull energy. Utilizing these estimations of the pace of the universe's extension, we can characterize different edges, different skylines, which limit our communications with the external universe. For instance, the supposed molecule skyline is the best distance which a molecule of light might have gone since the huge explosion itself, basically, which was 13.8 quite a while back. Presently, you could gullibly feel that that implies the distance ought to be 13.8 billion light-years, but since of the development of the universe, it's really a lot more noteworthy distance, turns out to be 46 billion light, a long time across. Presently returning to our spaceship experience to make a full circle over vast distances, then this extension makes the distances between locales continuously develop during my outing, meaning I need to travel farther than I suspected I did. Presently, this isn't significant, assuming you're going inside a gravitationally bound district, similar to a system, say, that opposes the development. Be that as it may, it is vital as we journey past our cosmic supercluster. As may be obvious, there is no past notice or computation of a full circle skyline in the writing. However, we ought to have the option to work out it by tackling the accompanying arrangement of conditions. I'll connect to a paper down beneath where you can realize about how to do these sorts of estimations yourself. However, to save you that aggravation, the subsequent legitimate distance ends up being 8.3 billion light-years away. This distance addresses an inestimable final turning point. When you cross it, there's no approaching back. You could always be unable to get back home in any event, going at the speed of light. Furthermore, that is on the grounds that the development of the universe basically outperforms you, and yes, space can and grows quicker than the speed of light. So it would be a bizarre inclination on board the boat as you pass that boundary, realizing that regardless, starting here on, you could at absolutely no point ever get back and see the Earth in the future. Since we can't get back past this point, we should not actually attempt. How about we change the principles of our outing and make it a one-way ticket? Presently, I'm actually going to expect that the final part of our process is a deceleration stage, where we grind to a halt, and that is essentially on the grounds that it's undeniably challenging to discuss how long has passed by, except if we return to similar inertial edge of reference from which we left. Presently freed from the need to return home, you could expect that we can go far further into the universe, maybe even to the edge of the discernible universe. However, once more, the response is no. Regardless of whether we speed up always, we won't ever make up for lost time to the supposed occasion skyline, which lies at 2 times the final turning point. This addresses the best distance which a light emission transmitted from Earth currently might at any point reach in endless time. Since parts of the universe are growing at the speed of light, then we can never make up for lost time to such districts and subsequently turn out to be restricted to distances inside this alleged occasion skyline. However, what in blazes? I mean, we've come this far. How about we simply continue onward? After this point, we're not exactly a spaceship any longer in light of the fact that regardless of how hard we attempt, we never find the occasion skyline. Also, as a matter of fact, the remainder of the universe around us grows away this way and that, ever quicker. Before long, there are no cosmic systems, doesn't no bunch anything around us as the universe grows ever quicker past our view. We become secluded, caught in the void. In the event that we're not exactly a spaceship any longer, maybe we've turned into a time ship? Might we at some point utilize a boat to head out to the furthest limit of time itself? Presently positively assuming that you gullibly utilize the conditions of extraordinary relativity, things absolutely look outrageous. For instance, with a speed increase and deceleration stage traversing 2 centuries by the boat's clock, a clock back on Earth ought to have recorded 100,000 trillion years. Enough time that even protons would have hypothetically rotted to leave no nucleonic matter left. Be that as it may, here's what it doesn't actually appear to be legit to try and discuss time enlargement any longer. What's more, that is on the grounds that time expansion is characterized as being relative, consequently the name relativity, to our underlying inertial edge of reference, which for our situation was the Earth. Yet by this point, after such a lot of time in the wake of crossing such countless light years, the Earth lies past our grandiose skyline. We are not generally causally associated with it. Put another way, contrasting timekeepers with those back on Earth is currently in a real sense unimaginable. To exacerbate the situation, not exclusively can you not come close to Earth's clocks, however you couldn't come close to some other clock by this point. That is on the grounds that at this point the universe has extended by a variable of 10 to the 10 to the 55, and genuinely there would probably be no different particles inside your whole perceptible universe, with the exception of you. Indeed, even the grandiose microwave foundation has dispersed to nothing at this point. How might we try and discuss estimating time, contrasting clocks, when the tickers really exist in discrete universes by this point? The very definitions supporting time enlargement have really unwound. Thus, here at long last, your process comes to a nearby, in complete seclusion, an ideal void. You and your team have turned into a landmark to times that used to be, to a universe that used to be. Furthermore, maybe as you and your group at long last pass away into the evening, you recollect that portentous day that you consented to step on board this vessel, to be gotten into a burial place that rushed into nothingness. The universe right presently is in its childhood. We live in its prospering a long time with stars shining across the sky, and maybe life also multiplies across the universe. This is all there is to it, brilliant time, and we are a result of it. There will never be been a superior chance to be alive, and there presumably at no point ever will be in the future. Like all things, the universe should ultimately end. Yet for the present, we have a second in the sun, mid-year days, to live, develop, and work by.